I'm going to solve 8 proportion problems. I think there'll be all 8 in this video. And you'll notice usually that proportion problems, you're given 3 values, 100, 3, and then 36, 39. And you're asked to find the 4th value. So that's very common with proportions. Here 1 inch, 9 feet, 3 2/3 inches, and you're asked to find the 4th value. For this number 3, it's not quite so clear. That's 1 bag and 2,500 square feet. But these 2 numbers here combine to give you 1 number. So again, you're given 3 numbers and you're asked to find the 4th. And on number 4, you might not see 3 numbers jumping out at you, but 6 out of 10. So there's a 6 and a 10. 27,000, you're asked to find the 4th. So that's a common pattern in proportion problems. Not all these problems require that you strictly use only a proportion to solve them, but that's what we're advocating, and oftentimes it's a good practice. It's a good way to organize your thinking. Okay, we'll zoom in a little bit and get going on this. So for our first one, basically whatever order the information is presented to me, I just stay with it. So first they mention Earth and then Pluto. So I'm just going to put Earth over Pluto and I'm going to stick with it. Okay, I just follow that pattern. And if it's a proportion, I'll have a fraction equals a fraction. So let's see, Earth to Pluto is 100 to 3. So there's our 100. There's our 3. The buffalo weighs 3,639 on Earth. So I wouldn't put it on the bottom. I would put that value on top because that's where Earth is. And find the buffalo's weight on Pluto. That's where the variable goes. Okay. And I've been encouraging an easy way to solve these that still works when you get more complicated problems is just clear this of fractions, multiply each side by 3x. So 3 times x, well I don't even need a dot there, but 3x, okay? And then you just go back and cancel what you can before you multiply. So the 3's cancel. I have 100x equals, the x's cancel, and I have 3 times that big old thing. I'm not going to actually multiply it. I'm just going to say that I'm going to multiply. And I'll hope for something better to show up. Looks like this one's still going to be a bit of a pain though. So you're still solving for x, divide by 100, divide by 100. Usually something cancels easily, but this one's just being a problem. So I'm going to have to go ahead and multiply these two, but dividing by 100 will be easy. So 3639 times 3. So we end up with 10,917 over 100. Those cleaned up right away. X is equal to that. And we could clean this up pretty quickly. Divide by 100 just means we'll have to divide by 100, we'll put our decimal in and just move it in 2 spaces. That's a nice shorthand way. So on Pluto, the buffalo weighs 109 pounds and 17 hundredths. Oh, did they ask us to round it? Oh, round to the nearest pound. Whoops, that's what I get for not reading. Round to the nearest pound. So that would be about equal to 109 pounds. There we go. And taking a look at number 2. These scale questions are very common. So we have an architect's blueprint. And again, I'm just going to put this on paper in the order that it shows up. So on the blueprint, 1 inch corresponds to 9 feet. So I'll just say blueprint and real world. So we'll go blueprint over real world. And then just stick with that arrangement. Alright? So I'll have a fraction equals a fraction. So blueprint, that's 1 inch, corresponds to 9 feet in the real world. So that's 9. I'll put my units here, but I'm not going to worry about them too much. The length of the wall represented. Okay, so the line on the blueprint is 3 2/3 inches long. I'm going to be multiplying and dividing here, so I do not like having a mixed number. Let's change 3 2/3 to an improper fraction. If it was easy to turn it into a decimal, we might do that, but we would have to round it if we did that. So let's keep it as an improper fraction. So that'll be 9 11 thirds. And let's see, find the length of the wall. So in the real world, how long is that wall? And again, I was saying just multiply by the product of 9 and x on each side. So here's 9x, 9x, and we'll cancel whatever we can. 9 cancels 9, you're left with x. X cancels x, you're left with 9 times this. So let's make that 9 over 1 times 11 thirds. And notice we have a little bit of canceling here right away. 3 goes into 3 once, 3 goes into 9 3 times. So all we have to do is multiply 3 times 11. And we get x equals 33. It works out that not only is blueprint on top, but inches are on top, feet are on the bottom. So this is a 33-foot wall in real life. Alright, take a look at the next one. Number 3, bag of fertilizer. You could certainly solve this without using a proportion, but since we're on a proportion kick, we'll solve it using proportion right now. And let's see, a bag of fertilizer, that's a one bag, covers 2,500 square feet. So they're giving us, the order that the things are showing up here are bag of fertilizer and coverage. So that's the order I'll stick with. I'll put number bags over coverage. And I just stay with that pattern. Okay? Let's get ready for our proportion here. So 1 bag, coverage is 2,500. How many bags? A rectangular lawn 370 feet by 220 feet. I want the square footage here. I don't want to put these two numbers. There is a cool trick though. In order to find the area, I would multiply length times width, so I would multiply these two numbers. But rather than multiply them, I'm just going to say that I'll multiply them. But I haven't gotten around to it yet. I'm busy. Okay. And I was saying that we can get rid of these fractions, the denominators, if we multiply by the product of, if we multiply each side of the equation by the product of this denominator and this denominator. So times 370 times 220. I'm going to do that on each side. All right, and I'm writing all this and I'm showing it to you, but once you understand the pattern, you can do some canceling pretty fast. But let's proceed now with what we have. 2,500 certainly cancels 2,500, and this is just 1 times those two numbers. Times 220 equals. These two numbers cancel those two numbers, and I'm just left with 2,500 times x, and now we want x by itself, so we just divide each side by 2,500. That cleans up real fast. And notice over here we can do some canceling with very little trouble. Divide by 10, divide by 10. And you can also divide by 10, divide by 10. So there's a lot less to worry about. There's still a fair bit though. So 37 times 2 times 22. I'll have to move out a little bit here. And obviously we'll get the same result. So that's 814 over 25. So we just have to divide 814 by 25. That won't be too bad. Into 81, that's 3. That's 32. But if we want to be sure that we can cover this lawn, we had better round up. All right. So I would say we need 33 bags. All right, moving on to the next one. Number 4, 6 out of 10 adults. We can zoom back in a little bit here too. And again, whatever order they give us this stuff, we'll just stick with it. So there's a 6 out of 10 buy their drugs at a large store. So we have number of adults in city over number of adults use large store. All right. Maybe you can think of a way to say that in fewer words. That would be fine. Try to get all this in here. There we go. But I just stick with the pattern once I settle on it. And let's see, 6 out of 10. I can't just put 6 and 10 blindly. I have to pay attention to this. If there's 10 adults in a city, that's on top. 6 of them are using the large store. There's 10 in the city, 6 use the large store. So that's 10 and that's 6. Okay? It actually doesn't matter how you set this up. What matters is once you decide on it, you have to stay with it. Okay? And that's what I settled with, so I'm going to stick with it. Then let me see. The city has 27,000 adults. So the number in the city is 27,000. I'm sorry. That's, oh, it is 27,000. Yeah. And so how many would use the large drugstore? So there's our X. So if we just multiply each side by 6x, a lot of stuff will cancel quickly. 6's cancel. We have 10x equals, the x's cancel, 6 times 27,000. And again, I'm not actually multiplying them until I know I have to. All right. So divide by 10. Divide by 10, and those zeros cancel. We'll divide by 10, divide by 10. And all we really have to multiply is 2,700 times 6. So it looks like there's 16,200 customers showing up at those large drugstores. For number 5 and number 6, they're giving us similar triangles here. Okay. Given that the pair of triangles is similar, we'll find the missing length. So we just have to keep the correct sides corresponding. So first we'll look here at number 5. We have a big triangle and a small one, so that's how I'll organize my thinking. Big, small, and I stay with it. And again, you have to be careful with the sides. The X definitely has to show up. So this is on the big, so this is going to go up top. This side here is X. The corresponding side on the small triangle is a 3. So I have big over small. So that's X over 3. And now I could pick the 2 bottoms or the 2 hypotenuse. It really doesn't matter. I'm going to, again, it doesn't matter. I'll pick the bottoms. So the big one, we've got a 12. And the small one, we've got a 4. Again, I'll stick with my pattern, but 3 times 4, 3 times 4, cancel what you can. 3's cancel. You've got 4x 4's cancel. You've got 3 times 12. Get rid of your 4. And 4 goes into 4 once, goes into 12 3 times. So this missing side right here is a 9. If you had picked these two sides, you would still get x is 9. Okay, we'll take a look at the next two. And again, they seem to give us a big and a small. Maybe I'll work these off to the side. These numbers are getting a little larger. So I have big over small. Stay with that pattern. Alright, so we've got the x, you got to make sure it shows up in your calculation. So this bottom side, x, is the big. Goes right there. The corresponding side on the small one is 28. Then I could pick the 21 and the 27, or I could pick the 18 and the 14. I think I'll pick the 18 and the 14 just because they're smaller. Alright, so the big is 18, the small is 14, and we'll stick with our pattern. Again, there's other ways to solve it, but I'm just doing the same approach each time to reinforce it. I can say 28 times 14 multiplies on this side of the equation, and I can say 28 times 14 multiplies on this side, and then just cancel whatever I can. So 28's cancel, and I have 14x, and the 14's cancel. I have 28 times 18, and now we just want to get rid of the 14. So divide by 14. Divide by 14. It's fine to notice that that goes into 28 twice. So 14 goes into 14 once, it goes into 28 twice. And over here, certainly the 14's cancel. So you have x equals 2 times 18, 36. So this bottom side here is 36. Alright, we're going to do 2 more. Number 7 has, oops, getting a little glare in on you there. Number 7 gives us a description of some numbers or relationship, and we're going to have to solve. This will set up as a proportion. Let's follow this closely. 3 times a number added to 8. 3 times a number added to 8. So here's my 8, and I add to it 3 times a number. Is divided by the number plus 7. So is divided by the number plus 7. The result is, well, there's where the equal sign shows up. The result is 4/3. 4/3. So we just put 4/3. Alright, and using the same pattern I've been using all along, I'm just going to multiply each side of the equation by this denominator times this denominator. So I'll write that as 3 times x plus 7, 3 times x plus 7, and now cancel whatever we can. So the x plus 7's cancel, and you're left with 3 times all of this, 8 plus 3x equals, the 3's cancel, but you have 4 times all of that. Okay? And now we'll have to get rid of these parentheses and go from there. So send in your 3, 24 plus 9x, send in your 4, distribute the 4, distribute the 3. 4x plus 28, and usually I solve this in 2 steps, but we're going to speed things up a little. I'm going to get rid of the 4x because that one's smaller than 9x. So I'll say minus 4x, but in the same step I'm going to end up with an x on this side, so I need to get rid of the 24, subtract 24 and subtract 24. So I can do this in one step. That's a 0. This is 5x. That's a 0. And this is a 4. And one more step to get x by itself. Simply divide by 5. Divide by 5. And we have the value of x is 4/5. Okay, 5 divided by the sum of a number and 11. So here's 5 divided by the sum of a number and 11. And because of the word sum, we put that plus sign between them. Minus so there's our minus. Let's see, what do they want now? The quotient of 3 and the difference of the number and 11. So quotient means we're dividing, so we'll have a fraction. 3 and the difference of the number and 11. Here's a number and 11, and because they use the word difference, we put a negative sign in there. Alright, then is equal to, well, they're not being very mysterious there. Alright, so is equal to 6 times the reciprocal. Oh my goodness. 6 times the reciprocal of the difference of the number squared and 121. Alright, the number squared, I'm going to write it off to the side and then put it up there. The number squared, and I'll put it up here. Alright, whoops, that's way off. There's the number squared, and 121. They want the difference, so we put minus between them, and 6 times the reciprocal. So the reciprocal of this will be 1 over, so let's do the reciprocal. 1 over, sorry, now I'll put it over here. 1 over x squared minus 121. This is the reciprocal of the difference of the number squared and 121. And they said 6 times it. I could put that 6 in front, but I can also put the 6 up top. and that's what I'm going to do. So we end up with 6 over x squared minus 121. That was a fair bit of work to get that set up. Okay, notice that x squared minus 121 is a difference of squares. And over here we have the actual difference of squares. So instead of having to write x squared minus 121 times this, I'm just going to write x plus 11, x minus 11 over each term and cancel whatever I can. Okay? So here's our x plus 11, x minus 11. Pen's a little thick for so much writing. Then x plus 11, x minus 11, and finally over here, x plus 11, x minus 11. All right. And now we'll be able to cancel quite a bit. So x plus 11 cancels x plus 11. We have 5 times that. Minus, this minus is right here. Then x minus 11, x minus 11. We have 3 times that. Equals, and x squared minus 121 is this. This is just the factored form. So this becomes a 1 times 6. So that's all we have there. All right. And we do still have to solve for x. So send in the 5 and the 3. Distribute it. So we've got 5x minus 55. Send in the negative 3, or distribute negative 3 to each term. Minus 3x minus 33 equals 6. We'll combine like terms. The 5x negative 3x gives us 2x. So that was the negative 3x, and the 5x gave us our 2x. Negative 55, negative 33 combined to give us negative 88, and that's still equal to a 6. Get rid of this 88. And we've got 2x equal to 94. And now just divide each side by 2. X is, well, the 2's cancel, and we have x equals half of 90 is 45, 46, 47.